Hello, all you cool cats and kittens. I'm here to do lesson 7.1 with you. Your learning target for today's lesson is I will be able to use equality and inequality symbols. So equality, that's just going to be an equal sign. And inequality are the greater than and less than symbols. So greater than faces the right, and then less than faces the left. All right, your think about it says, for each balance below, decide if the balance will tip or it will stay even. Then place an equal sign, a greater than, or a less than sign in each box and explain why you chose the symbols you put in the box. Go ahead and pause the video and see if you guys can figure it out on your own. All right, guys, we're back. So if we look at letter A, we have 6 plus 4 plus 2 on the left and 4 plus 2 plus 6. So we're using the same three numbers, we're just changing the order of it. So the commutative property is at work here. Commutative property tells me that I can move things, add-ins or factors around, and it doesn't change my final answer. So just to prove that correct, if we do 6 plus 4, that gives us 10, and 10 plus 2 gives us 12. And on the right-hand side, we have 4 plus 2 gives us 6, and 6 plus 6 gives us 12. So they're equal. We know it's an equal sign because it's demonstrating the commutative property. So I chose equal because the commutative property is demonstrated or applied. If I simplify, both sides equal 12. So an equal sign shows when two expressions have the same value, such as in example A. Example B, on the left side we have 12 minus 3, and on the right side we have 7 plus 1. So these are different numbers, so let's go ahead and let's solve the left side first. 12 minus 3 gives us 9. And 7 plus 1 gives us 8. So 8 is greater than 9, so I need the mouth of my alligator to be open to the 9, where the mouth is always open to the greater number, and the greater number is 9, so we want that mouth open to the 9. So we chose greater than, because after simplifying, both sides, we get 9 and 8. And 9 is greater than 8. All right, last example for your think about it. We have 4 plus n plus 7 on the left and n plus 8 plus 4 on the right. Let's go ahead and simplify it. We have some like terms, these constants, we can add them together. So we have n plus 7 plus 4 is 11. Okay, and then we have constants again that we can add, positive 4 and positive 8, that gives us 12. So the right side is n plus 12. So if we look at both sides, the n is the same. So we need to compare the constants. We have positive 11 and positive 12. We know that positive 12 is larger than positive 11, so we have to choose the less than symbol. So I chose the less than because after simplifying both sides, I'm left with n plus 11 and n plus 12. They both have n, and 11 is less than 12. So that's why we chose the less than symbol. So I'm going to just quickly write above the symbol again what it means, because I know that we get these confused sometimes. Okay, so an inequality symbol then, which is a greater than or a less than symbol, shows that two expressions do not have the same value. So an equal sign will show a same value, and an equality sign will show you a different value. They won't be the same. Okay, let's move on. So we have a key point for today's lesson. Our key point says that equal signs and inequality symbols are used to compare two expressions. So just one more time, I'm going to say that inequality symbols are greater than and less than. All right, number 1. Which symbol would you use to compare the two expressions below? So first thing I want to do is I kind of want to mark up my text. These two symbols right here we just learned are going to give us an unequal, or where the values are not the same, and the equal sign is going to give us an equal value.
Obviously.
Okay, so the first thing that I want to do is I'm going to rewrite both expressions out so that we can work on simplifying them. Let's start with the first expression. So I do have some like terms here. We have positive 5 and we have positive 10. So positive 5 plus positive 10 gives us positive 15. And we have to bring down our 2n. Now 2n and 15 are not like terms. I cannot add those. I would need the 15 to have an n, but it doesn't. So those are unlike terms and I cannot add them. This is the most simplified. Okay, let's look on the other side, example number, or expression number 2. I'm going to use the commutative property so that I can group the like terms together and it will be easier for me to simplify. So I've got two sets of like terms here. I've got positive n and positive n. And then I have positive 8 and positive 7. So 1n plus 2n, or plus another n, gives us 2n. And then positive 8 plus positive 7 gives us positive 15. So it looks like we got the same expression, meaning that these expressions should be equivalent. We can check our work by using substitution and plugging in some numbers into these original expressions, this here and this here. So let's do a check. Let's say n is going to equal 2. So for the expression number 1, we have 2 times n, which is 2, plus 5, plus 10. We have to follow the order of operations, so we do multiplication first. 4 plus 5 plus 10. And we get 4 plus 5, which is 9. Bring down our 10, and 9 plus 10 gives us 19. Let's check the second expression. So we had n plus 8 plus 7 plus n. So we got to replace the n with the number 2. So 2 plus 8 plus 7 plus 2. So let's add these up. If we get the same answer, then we proved our original work correct and we can move on. So we have 2 plus 8 gives us 10. Bring everything else down. 10 plus 7 gives us 17. Bring everything else down. And 17 plus 2 gives us a final answer of 19, which matches the first expression. So they are equivalent. All right, let's move on to example number 2. Assuming that x is a positive number, is the comparison true or false? Show your work. So let's go ahead and annotate our text and let's remind ourselves that that symbol right there is the less than symbol. Okay, so we're looking for our left side to be less than our right side. So let's go ahead and rewrite these problems down and we'll work on simplifying them. So we have 2 times the quantity of x plus 4 plus x. Then on the other side, so the second expression, we have 8 plus 2x. So starting with the first, I do see that we have a factor outside of a set of parentheses, and so that tells me I have to use the distributive property. So I'm going to distribute my 2, and you know that when we distribute and they hit each other, they multiply. So 2 times x would just be 2x. Got a plus sign, so let's bring that down, reload, and distribute to our second term. Again, when they hit, the terms are multiplied. So 2 times 4 gives us 8. And then we bring down that last x. Now, just like we did with example number 1, I'm going to use the commutative property so that I can group the like terms to make them easier to add. So we have 2x plus x plus 8. So 2x plus x, well, that's adding a third x, so we have 3x. Plus 8, we got to bring down our 8. So it looks like the only difference we have here is on the second expression we have 2x plus 8, which I'm going to use commutative property again to switch it around just so it's more similar to the first expression. Okay, I'm going to move that up here so I can show my work or check my work. So just like we did with the first one, the first example, we need to check our answer. So let's check our answer. Remember, it said that x has to be positive, so we'll pick positive 2. You know I like to use 2 when we check these answers with substitution. So x is going to equal 2. So let's plug it into the first expression. Again, we're starting with these originals. Okay, so we have 2, and then replace x with 2 plus 4 plus 2 again. Okay, so we have to do what's inside parentheses first. 2 plus 4 is 6. Bring everything else down. Now we got to multiply. 2 times 6 is 12. Plus 2 gives us a final answer of 14. So let's check the second expression now. We have 8 plus 2x. Again, we're substituting x with the number 2. So 2 times 2. We got to do the multiplication first. So 2 times 2 gives us an answer of 4. Bring down our 8. And 8 plus 4 gives us a final answer of 12. Which is bigger, 14 or 12? 14 is bigger, right? So we would use this symbol where the mouth is open to the left side of the expression. Is that what we did here? Is that the same expression or the same symbol as what we just did? No, this symbol is the greater than symbol. So let's actually go ahead and correct the expression. So all I'm going to do is I'm just going to rewrite it, but I'm going to use the greater than symbol since we figured out that's what was true. X plus 4 plus x is greater than 8 plus 2x. Again, the difference was this was asking us for less than, and we determined that that was false. It's actually greater than. And we checked our work by plugging in or substituting 2 for x. And when we did, our left expression is greater than the right expression. So that's why we have to change it and give this as our final answer. All right, guys, we will see you for our Zoom meeting. I hope you have a great